Hey folks, welcome back to our unit on right triangles and trig as we wrap up the entire unit with our second video of angles of elevation and depression. So in the last video we spent a lot of time talking about the vocabulary of angles of elevation and depression. We did one example, and now what we're going to do is a whole bunch more examples. So if you don't recall the notes from the last lesson, here they are real quick. Know what the angles of elevation is, know what the angles of depression are, and know what they are not. Okay, so make sure we have that from the last video. And let's just jump in and do some more examples. That's all we're going to do in this video, more examples. So now we're going to use the angle of elevation. So here we have a situation, and we sight a rock climber on a cliff at a 32-degree angle of elevation. The eye level is 6 feet above ground. Okay, so that's going to be important, 6 feet above the ground. So that means the ground is somewhere down here, okay? And we have to remember that, because remember that note, we don't look from our feet. We are 1,000 feet from the base of the cliff. That makes sense. What's the approximate height of the rock climber from the ground? So we have a climber and the ground. So what we're doing is missing a certain distance from our eye level, our line of sight, to the rock climber. And so we have a 32-degree angle of elevation. We have a distance from the base, and we're looking for a thing. So when you look at this, back comes Chief SOHCAHTOA. And we want to wonder, hey man, what trig function are we going to use to figure out that height? So from the angle, we're looking at the opposite leg and the adjacent leg. Good old tangent comes back. So we're going to look at the tangent of 32 degrees. And the tangent of 32 degrees would be the opposite over the adjacent, would be x over 1,000. So in order to figure out what that x value is, we will just solve the equation. And so we solve by multiplying both sides by 1,000. So we multiply both sides by 1,000, and we will know that x would be equal to 1,000 times the tangent of 32. So in comes handy-dandy calculator. And so we'll perform that function, 1,000 times the tangent of 32. 32, tangent button, and then equals. And so we find that x is some crazy number, and we go back to the problem. Are we rounding anything? Do we have to round? And the question deals with, well, what is the approximate height? Okay, so let's approximate. So we approximate this crazy number on the calculator, 624.869. I'm going to go ahead and approximate that as 625. Okay, that's a nice approximation. So x would be 625 feet. Now, is that the answer to what we need? Is that the height of the rock climber from the ground? No. That's only the height from the line of sight to the rock climber. Okay, so it's 625. So the old segment addition postulate comes back. How tall is the actual height? We need to add our 6 feet. Okay, because we are 6 feet above ground level. So we add our 6 feet, and so we have our height of the climber from the ground would be 631 feet. Which is that approximate? I would say 630 feet would be more approximate, but either way, you get what I'm saying. And so we have to recall that we don't look from our feet, we look from our eyes, and we have a distance off the ground. And that's a warning, right? We have to be careful with what's happening here, okay? More examples. All right, so more angle of elevation stuff. All right, so this girl, Missy, I'm guessing that's a girl, stands at a horizontal distance of 45 feet from the base of the building. Okay, there's Missy, 45 feet from the base of the building. The angle of elevation is 48 degrees. What is the height of the building to the nearest foot? Okay, so we're going to look for the height of the building from the nearest foot. Now, does it say that Missy is looking at the top of the building? No, it just says the angle of elevation from Missy. Doesn't mean she's not necessarily looking. Okay, so it's not eyes. We got to be careful. So this one we don't need the segment addition postulate. So the angle of elevation from her to the building is 48. And so all we're going to do is find that missing height, right, from the top of the building. Once again, tangent comes back to play. Man, tangent is such a great function. I hope you know that. So tangent of 48 degrees would be x over 45. And so all we do is solve for x. So we multiply both sides by 45. So 45 times the tangent of 48, and we will have our result. Okay, so 45, handy dandy calculator, times 48 tan equals 49.977. But we got to read, back read. What is the height of the building to the nearest foot? So it's to the nearest whole number, to the nearest one. So it's 49.97, that's 50. Okay, so we're looking at 50 feet. Is it feet? Yep, 50 feet. So the height of the building is 50 feet. And that's how that works. All right, next question. A flagpole in Terry's schoolyard, all right, is 42 feet tall. On a sunny day, the flagpole casts a shadow that's 20 feet long. I'm going to stop there and draw a picture. Here's a flagpole. Bloop, bloop. Flag. It casts a shadow that is 20 feet long. Okay, so there's a 20-foot shadow. And the flagpole is 42 feet tall. Okay, so why am I laughing? Clearly, this diagram is not to scale. What is the angle of elevation of the sun at the moment? What? Okay, so that it's casting a shadow. Bloop, 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 bloop. So the way shadows are cast from a sun is, you know, the sunbeam, right? So the sun hits the flagpole, casts a shadow there. The question is, what is the angle of elevation? Okay, whoa. So we need to figure out what the angle of elevation is. Now, if we're looking for an angle, do you remember from the last lesson what we're going to use? I hope you know. An inverse trig function. An inverse trig function. We're still dealing with tangent, I hope you realize. The tangent of opposite over adjacent. Okay, so the tangent of the angle would be equal to 42 over 20. And so what we need to do is figure out what the angle is. So remember, that's the arc tangent. Okay, so we want to calculate tangent of -1 of 42 over 20. So that's how that works. So you remember in our calculator from the lesson on trigonometry, hopefully you remember that. If not, you better watch that. Anyhow, 42 divided by 20 gives us a number, and we're going to figure out the arc tangent. So the inverse tangent button, 64.53. So guess what? 64.53. There's our angle measure. So that is the angle of elevation. I'm gonna stop the video here, not because my sixth period bell just rang, because that's it for angle of elevation. I'll come back and finish another video about the angle of depression later. Okay, so see you guys on the flip side.